Hello, sir. Good evening.
Hey, hi, hello everyone. Good evening.
Good evening,
Sir,
sir.
Uh,
I have a doubt, sir.
Good evening, sir.
good
Sir,
evening. Good
actually,
evening.
sir, I'm not able to do peer review, sir. They are not giving access.
Okay, so for peer review, I guess we'll be having a session. Like they'll tell you. I guess a session has already been done, right, regarding the
Ah,
peer review. Correct?
No, sir.
sir, what?
Actually, this issue is being faced by the students only those that didn't get the college ID.
Okay. Okay, and then then okay, so regarding this peer review, we'll have to talk. We'll have to talk to the other person, like to the team members, and then only will be maybe a session of
But,
half an
sir,
hour
I'm
or.
a thousand times also pressing the button, but it's not working, sir.
I'm
Sir,
getting your
it's not
point.
Yeah, you
working for
have
many
emailed
students.
them and
Yeah,
they are
I'm
responding.
getting your point. I'm getting your point. Yeah, that's why I'm saying that this is like many people are facing this. So we'll come up on something. Okay, so maybe a
Sir,
session or something.
actually,
Yeah.
sir, actually, I had submitted the activity, and
Mm-hmm.
I got two peer review in which they
Mm-hmm.
are saying data is absent. I went and checked the link. Your submission was there, and I went and checked over there. It
Mm-hmm.
was no data was present. While I checked from another window, where I can
Mm-hmm.
access through other window, the data was still there over there. But in the where from the portal, the
Mm-hmm.
whole data has been vanished, and I'm getting zero review.
No
Zero.
problem. So this is the issue. I know many of the people has asked in the discourse also. So will come upon something, okay, regarding the peer review. So you don't have to worry about the peer review thing. We'll be having a session or something on the Discord that will clarify
Like
how
whole
are we
data
going.
has been vanished, sir.
Okay, no problem. So don't worry about the peer review thing, the activity thing. Okay, we'll come upon something. Okay, many people are facing this, so we'll come upon something. Don't worry about that. Okay, so for now, you just worry
Okay,
about the
sir.
quiz two. Okay, after
Okay.
this quiz two, we'll discuss about that also, this peer review things. Okay, how are we going to manage it? Okay, don't worry. Okay, let's start with week 8. So I'll start with the discussion of activity and then practice. Okay, I guess the summary has been done. We'll just discuss the activity and practice today. And regarding the quiz syllabus, I guess the quiz syllabus has already been told to you. This is from week 5 to 8, right? So for
Yes, sir.
statistic 1, this is week 5 to 8. For mathematics 1 also, that is mostly 5 to 8. The maximum one questions can be from week 1 to 4. But 90 to
Got it, sir.
95% of the problem is from week 5 to 8. Okay.
Sir, in maths.
In maths,
Math and
most of the
1 to
maths,
eight.
maths 1, I'm saying it again and again. The syllabus is from week 1 to 8, but 90 to 95% of the problem out of some 17, 18 problem, you can get maximum of one or two questions from week 1 to 4. All the remaining questions are from week 5 to 8. Okay. Is it clear? For stats 1, all
Yes, sir.
the syllabus is from week 5 to 8. I don't know about the other questions, but these two questions I've clarified it 2, 3 times. Okay. Let's start with, I'll just start solving all the problems from activity to the practice.
Vishal sir, good evening, sir. Sir, just a minute, sir.
Yeah,
Hello, sir. Can you hear me, sir?
yeah, I can hear you.
Sir, regarding the extra activity, sir, we are not able to review, sir. Peer review is not available on our portal, sir.
I was discussing about the same thing like 2 minutes, 3 minutes before. So regarding
Okay.
that, regarding peer review, so there are so many people are facing the same issues. So
Yeah.
after this quiz too, we'll have some session or something where we'll
So,
try
sir,
to
we
come up
shouldn't
upon
worry
something.
about
Okay.
this peer review
Huh.
thing for
No,
now
Sir,
we
on.
should not.
yeah,
So
sir, we
there's
have
no
conducted a,
deadline for that.
yes,
So
sir.
there's no
Yes, sir, there
deadline
is,
for that.
So there is a deadline, sir, 30, sir, 30 July.
30th July.
Yes, sir.
Yes,
That's why
sir.
we all are so worried about that.
Okay.
We have also conducted a sir, poll in our sir, group, sir, and we have found that most of the students who are not having a student ID provided
They
by
are
IIT
facing.
Madras are generally facing this issue, sir. So you can check the
Okay.
poll, sir. I've posted the link also, sir.
Okay. So I'll go through that, but yeah. So
Yes, sir.
when is the okay? But I'll have to discuss this. This query has been there.
Yes, sir.
We are trying to sort it out, but okay. So this peer review things I'll discuss with the teammates also, and then only I'll be in the better position to comment on this. Okay.
Yes.
But
The
it's
please, the please forward,
maybe
sir, this poll link also, sir, so that they can have a clear idea of what issue we are
No,
facing.
it's with most of the students, sir.
yeah,
Yes,
yeah,
yes,
yeah.
sir. Yes, this
I
is the
get an
link, sir.
idea. Yeah. Mhm.
Now you can check the sir results, sir.
Mhm.
Yeah, most of the student who does not have this student ID are facing this issue.
Okay. If you got an idea, yeah. Hmm. I'll forward
Thank
this
you, sir.
also. Then, yeah. Thanks.
Okay, sir.
Thanks. We'll sort this out. Don't worry. So 30 to the next. Maybe the next session. When is the next session? Hmm. So I'll try to like we'll discuss it today itself. After the session, I'll just try to discuss, and then whatever comes,
Oh,
I'll do maybe in the this course or maybe in the next session. We'll clarify
okay,
this.
sir.
Okay.
Okay, sir. Thank you, sir.
Fine. Thanks. So we'll start week 3. I'll start with the activity first, activity questions, and then maybe practice, and then if the time permits, we'll go through the graded. I'll just give an idea about the graded, but mostly we'll be discussing the activity and the practices. Okay. So I guess the activity AQ, that is 8.1. All the questions are very basic. I'll just discuss this. This is regarding the contingency table that we have already discussed in some of the weeks, I guess, in the week 4 or 5. But even though, so the data that has been given to you is, so there is some profession that is been given, and then some three profession has been given, and some data has been given. So this profession is regarding out of this doctor 150. So the data is regarding a bank. The bank wants to analyze some how the the loan is defaulting. Okay, so there's like some relation between the loan default and the profession of a person. Okay, and this hypothesis has been done on some 2,000 people. Okay, and out of this 2,000 people, we have this data. So this is regarding the yes, the people has defaulted it, and this is regarding no, the people has not defaulted it. So 150, 350. Here it is 400, 900, and 200. Okay, and out of this, the first question. So, are you able to hear me? So, voice, you are able to see the screen. Everything is clear, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes.
sir. Everything is
Yes,
clear.
sir.
Okay. So, the first question is what is the probability that the selected person is here? So, probability that the selected person. So, randomly we are selecting some people. Okay, suppose the people is randomly chosen from this group. Okay, so what's the probability that the chosen person is a teacher? What do you think? What should be the value? So out of this total people, how many people? So the hypothesis was done on some 2,000 people. So altogether, we have some 2,000 people.
1200 by 2000.
Correct. So how many people are? So what's the probability of getting a person who is a teacher is like basically the total number of teachers that are present upon 2,000. Okay. So this is like the total number of people.
Favorable number of teachers.
Yeah. And then you have a favorable number or the sample space like favorable number basically. Okay. So this is simple. So you can just do it like this. The second question is, so you'll have to tell me what's the probability that the team has, what's the probability that the person has defaulted the loan. Okay, what do you think? What should be the value? So somebody has defaulted the loan. So whoever has defaulted the loan, the probability is basically the number of people who has defaulted the loan, number of people defaulted the loan upon total people, right? So this is regarding the person who has defaulted the loan. Okay, so you can see that whatever the number that you are getting, just add it upon 2000, right? Is this clear?
Sir, what does it mean by defaulted the loan?
Yeah, he just took some money and then he hadn't paid back. Okay,
Oh,
that's
so
like this.
okay, sir.
The third question, so this is clear. Then the third question was the probability that the person has not defaulted. So basically, this is like 1 minus whatever the value that you are getting. Okay, so here, let's for example, you are getting how much? 300 plus 50 plus 50 is 400 and 500, right? So this is basically 500 upon 2000. So 0.25 you are getting, correct? And if you have been asked to calculate the probability that the person is not defaulted, so the person that has been randomly chosen has not defaulted the loan. Okay, so that is basically 1 minus this probability that the person defaulted the loan. That will be 1 minus 0.25. That is basically 0.75. Right? Now the next question, what is the conditional probability that the person has defaulted the loan given that the person is a chef? Now the probability that you have to calculate is given that now you have been given some data. Okay, so the person who has been randomly chosen, that the information that you have already is that the person is a chef, the profession is chef. Now they have defaulted the loan. So he has defaulted the loan. Can somebody tell me how will you calculate this? If somebody is given people or the randomly chosen people, okay, that is already the profession, you already know that it belongs to chef. He's a chef, and then he has defaulted the loan. What do you think? What should be the probability value? Can you tell me?
50 out of 250.
Correct. So this should be what? 50 out of 250. So the total number of person who are chef is what? 250. But out of that, how many has defaulted the loan? 50. Correct. So you can get it directly from here. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yeah. So similarly, if you have been given some more questions, what is the question? So the next question is, the next one, what is the conditional probability that a person is a doctor given that the person has defaulted the loan? Okay, so now the opposite thing is there. So the person is asking that the person that you have chosen has defaulted the loan. So he has defaulted the loan. Now you have to calculate the probability that the person that has been chosen was a doctor. Now how will you calculate? So here it has been said that you have to calculate the probability that the chosen person is a doctor given that he has defaulted the loan. What do you think? What should be that? So how many people has defaulted the loan? So the total number of people?
150.
150. So now 150 people whose profession is doctor has defaulted the loan. But you have to calculate the given
150
people.
by 500.
Correct. So 150 by 500. So 150 is the person that belongs. So he's a doctor and made the default. Okay, and 500 is the total number of people who has defaulted the loan. So the given number was 500 upon 1. So 150 upon 500 should be the correct answer. Anybody has
So
any
is
issue
it
in
not?
this?
So is it
Yeah.
not 550?
No, it's like 300 plus 50 is 350 plus 150 is
Okay, sir.
500.
Okay, sir. I got it, sir. Thank you, sir.
So now next question, what is the conditional probability that the person has not defaulted the loan given that the person is a teacher? What do you think? So given that the person is a teacher and he's not defaulted the loan. So teacher not defaulted. What should be the value?
900 by 1200.
900 by 1200. Anyone has any doubt in this? Any of the question that we have discussed, anyone has any doubt in this? You
No,
can just ask.
no, sir.
No, sir. No, sir.
No? Let's move to the
No,
next
sir.
part. Okay. So there are some questions. So the first question that has been given to you is, the game club has 80 members. Okay, so there are some 80 members has been given. the number of members is 80, right? And out of that, it's said that the number of people who play chess is what? So chess is what? 70. And table tennis is 45. And who plays both? Okay. Basically, who are playing both chess intersection of table tennis is how many? 35. Now you have to tell me if a member of a club is randomly chosen, find the conditional probability that he or she plays table tennis given that he or she plays chess. Okay, so now you have to calculate that probability such that he or she plays table tennis given that he plays chess. This is what we have to calculate. How will you calculate this?
What the question, sir?
No. So the question is, so you have been given some data. The data was the total number of member in some club. So the total number of members in a club is 80. Okay. And out of that 80, 70 people play chess. Okay. And 45 people plays table tennis. 35 plays both chess and table tennis both. Now you have to tell me the probability says that he plays table tennis given that he plays chess.
0.5, sir.
How did you calculate that?
Table tennis, common between chess and table tennis divided by chess.
Yeah. So you just calculated. So basically the probability of C upon probability of what? T intersection C, correct? And the table, the person, basically you can directly write it as a 70 upon 35. This is how you have calculated.
Yes, sir.
Everybody got this, right?
Sir.
Sir, why we
Yes,
did
sir.
like intersection?
Yes, sir.
Why did
Sir, why did we
what?
did the intersection?
Intersection? Intersection. So the formula, what is the conditional, the formula for the conditional probability? So this formula is clear, right? You know this formula, right? The conditional one. The conditional is basically what? Joined upon marginal. This you know, right?
Oh, I didn't know this, sir.
Oh, okay. No, so this, yeah, so there's a very basic formula for the conditional probability.
Okay,
Okay.
sir.
Yeah.
Sir, sorry, Vishal, shouldn't the formula be n of t intersection c instead of p? Because we're not putting p, we are putting n.
You can put it n also. So if you put it n, so both 80 and 80 will get cancelled, right? So that will be basically 35 upon 80.
Oh, okay, got it, got it. Got it.
Okay, and then 70 upon 80. So that's why I
So
just
both formulas are
didn't put.
fine, correct?
Both are fine.
Okay.
So this is clear to everyone. Can we move to the next part?
Sir,
Yes,
I
sir.
wanted to ask something.
Yeah.
We have Bayes theorem also, right? That says like everything is same. No, no,
Mhm.
no.
So here you will use the multiplication rule, but there's no point of using the multiplication rule here
So,
because
so
the
I wanted to
information.
ask that only. When to use Bayes theorem actually?
So
The
Bayes
type of
theorem,
questions.
Bayes theorem, we'll discuss about that. Okay, I guess maybe after 10
Hmm.
15 minutes we'll go through the Bayes theorem itself. Okay.
अच्छा, okay, ठीक है.
So if you have explicitly other information has been given to you, then here it was nothing, but just you have been given all the like the intersection thing was given to you. So that's why you have used this formula directly. Otherwise, you'll have to use the other. Mostly the Bayes theorem will be where we'll be using the information regarding the total probability also. So where we'll have to calculate basically the PC also. So you'll have to use the concept of the total probability also, law of total probability, if you would have read about that, right? So in the Bayes theorem, you have to calculate the probability of this the whole things also. If the probability of getting how many people are playing chess, okay, and while playing chess, we'll have to the whole sample has been splitted down into some B1, B2, B3, and then you'll have to take a common from. So okay, I'll discuss that Bayes theorem. Okay. So first we are just going through the conditional. This was the first question, and it was pretty simple. Let's move to the second one. Okay, so the second question is we'll have to solve it. So there are n balls. So I'll just write it out. There are n balls in a drawer, of which 7 are red. If two balls are chosen randomly, then you have to calculate the probability. Then the given information is then the probability that both the balls are red. Both the balls are red is equals to 3 by 4. Calculate n. Okay, this question is clear. So basically you have n balls in a drawer. So there is some box you can just think of. In this there are n balls, of which 7 are red. So of which 7 are red. If two balls are chosen randomly, so two balls you are choosing randomly, one ball you are chosen, second ball you are chosen, then you'll have to tell me probability such that both the balls that have been chosen is 3 by 4. Then you have to calculate the value of n. What do you think? What should be the value? So this is not this easy. Here you don't have to even use the conditional like condition. You can just use your permutation combination uh, information or knowledge, and then you can solve it out.
7C2 by NC2.
What? 7?
C2 divided by NC2.
This also you can calculate. By this method also you can calculate it. This is also not wrong. The other method that I'll tell you. So if let's for example you have to take out red ball, right? Hello, everyone. Are you able to hear me now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, now tab. Okay, no problem. So we were discussing about that question where discussing that there are n balls and then you have to out of that n balls there are 7 red balls. What is the probability that you'll be getting a red ball? What do you think? What should be the value?
Sir, your screen is not visible.
It's not visible. I'll just. Okay. Give me 1 second. Okay. Yeah. Is it visible now?
Yes, sir.
Yes, sir.
Yes.
Okay. So what I was asking is, you have a n balls in some box. There are n balls, and out of that 7 are red. What is the probability that you'll be getting a red ball in the first turn?
Hello, sir.
7 of n, right? Yeah, yeah.
Sir, can I explain this question again?
Yeah. What the question was basically, there are n balls in a drawer. Okay. There is some box or something. There are n balls, and out of which 7 balls are red. Okay. Now the question, the given information is 2 balls has been chosen randomly. Then you have to, and the given information is while choosing the 2 balls, the probability that you are getting both the ball as red is 3 upon 4. Now you have to calculate the value of n. Okay.
सर आई
Yeah.
वन क्वेश्चन इट्स नॉट फॉर मतलब इसमें हम वो तो नहीं करेंगे क्या बोलते हैं आपका अरेंजमेंट फिर परम्यूटेशन कॉम्बिनेशन होना चाहिए
You can solve it with the permutation combination method also. Like somebody has told me 7c2. You're choosing a ball, 2 balls from the red is 7c2, and out of n you are choosing a 2 balls, right? So that can be one method. The other method is very simple. Like you know that both the balls are red, and you are using the method of a probability, right? So the probability that the first ball will be red is what? 7 upon n, correct? Out of n ball, 7 ball is red. So probability is what? Total number of balls upon the outcome, the favorable outcome. 7 balls are there. Now you have got the one ball as a red, right? How many balls
6
are
by
left?
n
6.
minus 1.
Correct. 6 by n minus 1. And that should be the probability of getting both the ball as a red. If we'll just solve this, we'll get the value of n.
8.
So if you solve 8, yeah, 8 I guess is the correct answer. N into n minus 1, and then if you just cut this out, upon 2 is 28. Yeah, so n equals to, I guess, 8, somebody has told is the correct answer. 8 into 7 by 2 is 28. Okay, is it clear? Is this question clear
Yes.
to everyone?
सर वेट आई विल सॉल्व दिस क्वेश्चन
Okay.
Can you please explain the above statement like 7c2 by nc2 is equals to 3 by 4?
Yeah. So this was solved, I guess. So whoever has said this,
No,
she has
we are
said it
getting the
like,
same answer, but
ha ha ha.
how?
You'll see. So what should be the probability of getting 2 balls as a red? So the first thing is what? If so, the ball is what? RR, right? Red, red. So out of 7 balls, you can choose it by 7c2, right?
Yes, sir.
And out of n balls, basically,
सर
yeah.
सर मैं n स्क्वायर तरफ कुछ जा रहा है जैसे मैंने अभी कट किया था nc2 तो n फैक्टोरियल अपॉन n minus 1 n फैक्टोरियल n minus 1 फैक्टोरियल और n minus 2 का फैक्टोरियल हो जाएगा ना मतलब इसको खोलेंगे सर
क्या?
तो जैसे हम लोग nc2 को निकालेंगे तो n फैक्टोरियल अपॉन n अपॉन 2 फैक्टोरियल into n minus 1 into n minus 2 फैक्टोरियल होगा ना
No. n
नहीं वो n
factorial
minus 2
divided
factorial
by
होगा गलत है
7,
सर
what is 7c2 is what? 7 into 6 by 2 upon
yes, sir, ये
nc2
सही
is
है
what?
21 आएगा
N minus 2. What's the issue? 2 got cancelled. So you're left with again the same thing, right?
yeah.
7 by n into 6 by n minus 1. Same thing, right?
yes sir
yes
okay सर समझ गया सर
Sir, can you please scroll down a little bit? Yes, sir. Thank you, sir.
Okay. Now the next problem is the third question. So the third question has been said that a card is randomly selected. So I'll write it out. A card is randomly selected, right? From the deck of 52 cards, from 52 cards that you already are aware of. What is the, you have to calculate, I'll not write it, I'll calculate. You'll have to calculate a conditional probability such that the card is a S card given that the card is a face card. You're already, what do you mean by face card? Face is that basically that you have how many? 13 cards, right? 13 of each.
13 cards.
Correct? What
King,
are those?
queen, and
So this is black, you can think of, and then red, right? In red, what are you having? Heart, I guess. Heart and diamond, I guess, right? And then you have club and spade, I guess, right?
spade. Yeah, sir. Yes.
Okay. And in this, you will be having face cards are what? Joker, king, and queen, correct?
Yeah,
Similarly for all the three faces. But there is nothing common, right? If you are just selecting the face card, like given what's the probability of getting the ace, given that the face card. So you don't have any card that are both like basically those are face card and then ace. No, right? So basically probability says that what will be the probability of this? Conditional probability is what? Here
Zero.
it should be face card.
0.
Yeah, correct. So ace, like there is nothing, right? So this is basically 0. There's no card that is face card and ace because face card is what you have joker, king, and queen. You don't have a like ace is basically one or like a that you called it as, right?
Yes.
So there is nothing common. So that's why the probability should be 0. Is this clear?
Yes, sir.
Is
Yes,
this clear
sir.
to everyone?
Yes, sir.
Okay.
Sir, Srimati ma'am already discussed these questions actually.
What?
Sir,
I think in one of the open session already we discussed all the activity questions. All of them were done.
Okay, these questions have been discussed already.
Yes, sir.
Okay.
sir,
Okay. Yeah.
sir, can I explain this question again?
Okay. So what this question was, a card is randomly selected from 52 cards. So the 50 that you already know that
Yes,
there
sir.
are 52 cards that you play. And then out of that you have to calculate the probability such that the given card is a face card. Probability such that the card is a S card, given that it is a face card. Are you getting me?
It's 452 because इसका तो बस 4 ही है.
S तो 4 है. That is fine. But here the question is, given that this is a face card, what's the probability that will be? So basically, how many face cards you have? 12, right?
What do you mean fish card?
Face card is basically that you have a joker, king, and queen are the face card. Okay.
3 for 2. Yeah, yes, sir.
Okay, you have 12 cards. But out of that, how many are S? There is nothing that is S, right? Because S are not the face card. If you have been asked to calculate what is the probability that the face, given that this is a face card, what is the probability that it is a joker, J? Then what should be the value?
It's 4 by 12.
4 by 12. Out of this 12, you have 4 joker, right? But you don't have any S, right? So that's why the probability should be 0. Okay?
Thank you, sir.
So
Sir,
the
पहले
both
वाला
events
question
are right
का-
now.
What?
Both events are right now the disjoint as well as it is independent event, right?
Disjoint. When do you call a set a disjoint? When
It's
the
a
basically
When
the
intersection is 0. When intersection is
Yes.
0, yeah, mutual exclusive.
intersection is 0, right? But independent, when do you call the independent? When basically your the intersection that you get is like that basically becomes probability of S into probability of S card, right?
Actually,
Okay.
when two events are mutually exclusive, they are highly dependent. If it is
Two
mutually
events-
exclusive, it is highly dependent.
No, it's disjoint.
No, those are disjoint sets
Yeah, disjoint.
because
Yeah,
you can't
no.
get anything common between those two.
Correct. But
Yeah.
there was a question on independent. Like, if
Where
two
is that?
sets are mutually exclusive, then they are dependent.
They
Yeah,
are
they can
dependent.
be dependent.
They can be dependent.
No,
Yeah.
no, they are dependent. No, like if two, they are not can.
There may be some cases, right?
No, it can't be.
Where
See, if they are mutually exclusive, if one event is happening, then the second event definitely will not happen. So it's dependent. So
Try
if two
some
events are
examples.
Not necessarily.
okay.
There might be a bigger sample space and they are just like
Yeah.
2 events out of it.
No, let's
Not
take any two events mutually exclusive. Like let's take ace and face card. Ace and
that.
face card. If ace is happening, face card will never happen. So if ace is happening, face card will never happen. So it is
No,
dependent.
why?
If ace is happening, face card will never happen. So it is two events are dependent, I'm saying. If face card happens, ace will never happen. So one event is dependent on the other. So all mutually exclusive events are dependent.
But like the definition of independent is that when you multiply them, it gives you the intersection of both the events E and F. But that would not happen for any case of disjoint. That
No,
In case
independent
of
E
disjoint
means
events,
intersection
if
of
the
F.
intersection is 0, so it means dependent only.
intersection is 0, so it will always be
Yeah,
dependent as
so
Intersection
long
it
as
is
is dependent
0,
only. Yeah,
but
it proves
we
that
cannot say
statement.
no, it's a true state. It's a
Yeah, yeah.
tautology
it
actually.
can be if one of the event is null set. So it will be 0
If
into some event 0. So still it will be uh, A intersection B is 0.
No, A intersection B is null set, and it is disjoint as well as it is independent as well. That is what I got.
yeah, it is correct.
No, that's Ilango. I'm actually
Thank you.
that's what I'm addressing. If a
Yes,
set is
that is true. That
disjoint,
is what I also going through. Yes.
yeah, if it is
Thank you.
disjoint, it can never be independent. Yeah.
Okay, once you'll join, then you'll clarify the issues.
It can be if one is null set.
Okay, let Sarah speak now.
Yeah. So what I was trying to say, so whatever she is saying is totally correct. So it's almost independent, okay, but there is an exception of null case.
Hello, sir.
Yeah. Are you able to hear me?
Yes, sir.
So
Yeah. So it's almost like always dependent, okay, but the nulls is an exception. So you can
So
say
can
that
you
it's all.
prove your sir of this formula by using this formula? It is not independent. Can you just prove it? So by using the formula A, the given B equal to the intersection formula is.
Let me think on that.
Means if A intersection B is equal to probability of A into probability of B. That is the formula, right? So if one is null event, then its probability will be 0. And disjoint also intersection will be 0. So it will be 0 into the probability of B, which is 0.
See, no. Is it visible? Screen is visible, right? So
No.
No.
it's not visible. Okay. One second.
Hello, sir.
Yeah.
Sir, just question number 2 था.
Yeah, 1 second. So just
Yes, sir.
now visible like this. If you have a disjoint set, right? So basically what happens if you have A intersection B is what? There's nothing common between them, right?
Yes.
Yes.
That is fine.
Yes,
but
sir.
From the starting itself, let's for example, if you have a one set that is null itself, then always the intersection will be null, correct?
Can you repeat what you said just now?
Yes.
No, what I'm trying to say is if you have a set is null already from the starting. A event is null. A is a null. Okay. B is anything.
It's okay.
This A intersection B is also null.
But that is null. It's not because those are dependent. It's because the one case is a null already. So what I'm trying to say is, so whenever you have a disjoint set, that will be almost every time always dependent. But there is an exception of this case only. But you can say that it's always dependent. Okay. Did you get the idea? Or not? This is what you were asking or something else?
Yes. Still I'm a bit confused. Yes.
Okay. So see, the opposite thing you can say, if A and B are mutually exclusive, you can say that they are not independent. That you can say. Okay, but you can't.
Okay.
Like, yeah. So this statement is totally correct. If A and B are mutually exclusive, then they are not independent. Yeah. Or do you need some more explanation?
Okay, no issues. Please continue.
Okay. So what the other people are so what is the question? Any what was the doubt? And somebody was asking in between.
सर क्वेश्चन नंबर 2
या
उसमें सर मेरा n स्क्वायर माइनस n माइनस 64 इज इक्वल टू 0 आ रहा है, तो क्या उसको पूरा निकाले क्या उसको
n स्क्वायर क्या आ रहा है? n स्क्वायर
n स्क्वायर माइनस n माइनस 64 इज इक्वल टू 0,
राइट? n स्क्वायर माइनस
n माइनस 64 इज इक्वल टू 0.
64. हाँ तो सही है ना? देखो नहीं नहीं n तो गलत कुछ कर. There is some error that you have done because 8 is not satisfying this equation. So it should be 56, I guess. N square minus n minus 56. That's why 64 minus.
Sir, 7 by
Yeah.
n into 6 by n minus 1 is equal to 3 by 4. 3 से काटने के 6 को, ठीक है सर, दो बार में कट जाएगा यहाँ पे. 7 2 जा 14, 14 4 जा, oh sorry sir, it's my silly mistake, sorry sir.
Okay, no problem. Okay. The next question is, so two pair dice has been, okay, so somebody is saying that we have already discussed the activity question. Is that right? So can we move directly to the practice or graded?
Also,
Or do I
continue
need to
activity
discuss
only,
it?
sir. Continue.
Okay. So here the fourth question is two pair dice. So two dice that is pair or like equally likely. Two pair dice are rolled. Now you have to calculate the probability such that probability. What is the conditional probability that at least one of the dice lands on 5, given that the sum is 11. So sum is 11. Okay, this has been given that the sum is 11, and then you have to find the probability that at least one of the dice lands on 15. 5, sorry, not 15. So one of the dice is 5. How will you solve this? Can you give me an approach? How will you start solving this?
क्या लिखे लास्ट में क्या लिखे?
No, I'm just asking you, can you get a sum 11 except 5? I'm just asking this question. Can you get, if you're just throwing a dice, two dice,
No,
can the sum be
because
11
no, because
except?
it's only possible if there is a 5 and a 6 on the dice. And if 5 is not occurring, then it's not possible that the total will be 11.
Yeah. So what should be the value?
It's 0.
1.
0, null set.
Null set, that is fine. But probability value should be what? 1.
0.
Right? It
One.
should be 1, right?
So
Every time you'll be
condition is
getting that.
1.
It's 1.
1.
Yeah, correct? Probability would be 1 because if you're getting the sum, if it is given that the sum is 11, every time you'll be getting like one of the two will be 5 for sure. Okay, because you can't get anything if you're just putting till 4. Like for example, till 4 you'll not be getting, because for till 4 you need 7 in the other case. That is not possible. The only possibility is 5, right? 5 and 6. Or 6, 5. So, but one of them is 5, right? So that's why the probability is 1. Is this clear to everyone?
Yes, sir.
Yes.
Yeah, yes sir. Yes sir.
Yeah. Let's move to the next step. 8.3. The questions are pretty simple. We have been given some box. A box is been given. So this is a box. And out of this, in this box, 8 white balls are there, 4 black balls are there, right? 2 balls are drawn at random, one after the other, without replacement. So you'll have to solve first without replacement, and second with replacement. Find the probability that both the balls are black. Okay, so find the probability that both the balls are black. Can you tell me? Somebody tell me the approach. How will you solve this? So first solve should be so this first ball should be a black. What's the probability out of this 12? How many are black?
4.
12
4, right? 4 upon 12. And in the next case, again, I need a black ball. So one has already been occupied.
3 by 11.
Okay, this is without replacement. That means if I am taking out the ball, I am keeping it in my pocket. Okay, I'm not putting again in the box. Okay, so
3
now
by
3 by
11.
11.
3 by
So this
11.
is without replacement. And if I'm talking about with replacement, what should be the value probability of BB?
4 by 11 into 4 by 11.
4 by 12
4 by
upon 4 by
11
4
or
by
4
12
by
into
12?
4 by 12.
12.
Correct. Anybody has any doubt in this?
No, sir.
No.
Okay, let's move to the next
Sir, can I
question.
explain again? Sir, can I explain again?
Okay, now what I was saying is there is a box, and that box contains 8 white balls and 4 black balls. And now you have been asked to calculate the probability such that whenever you are taking out two balls, you are just taking out from the box. What is the probability that both the balls are black? Okay, is it clear? So to get the first ball, because it's saying that without replacing, if you are just taking out one ball from here, so it's just minus one ball. So what will be left here? 8 white.
It's 8 white, 3 black.
Correct. We just taken out. Now, how many are left? 3 are left, and total 11 are left. That's why this should be the probability. And this is without replacement. And if you are replacing the ball, that means you're just taking out and again you're putting in the box. Okay. Now, so after, even though you're doing the subtraction of -1, you'll be left with, because again you're doing +1, right? You're taking out and then you're just seeing the ball. Okay, this is a black ball. Again, you're putting in the box. Okay. So again, you're adding it. So 8 white and 4 black again. So now again it will be 4 upon 2. Is it clear?
Thank you.
Yes, sir, clear.
Okay, let's move to the next one. So next question is, suppose you take out 2 cards. Okay, so can we do some other questions? If I have some other question, I'll do it like this, like similar to this. Let me check it. Okay, so there's one question. This is for everyone. If so, a family has 2 children. What is the probability that find the probability that both the child are girls, given that at least one of them is a girl?
Three by four.
1 by 3.
3 by 4 is not correct. Yeah, 1 by 3 is correct.
3
1 by 3.
3 by 4 रहेगा ना?
3
1
by
by
4
3.
is not correct. So given that at least one of them is a girl, what are the total possibility of that? GB, BG,
BG, GG.
and GG also, right? At least one of them. Correct? And out
Yes,
of
sir.
that, how many are
2 by
GG?
3, sir.
So out of this, how
One.
many are GG?
One done.
One upon 3, right?
Yeah.
Yes.
You can solve it the basic approach also. Basic approach can be, it's for example, you can just think of as a one event. E can be what is given. So this can be E, this can be F. Okay. How will you solve probability of E given F? How do you solve that? Probability of E given F, right? I have written F given F. Probability of F you have to calculate given E. Probability of E, probability of F intersection E. Correct? What is the probability of E? Probability of E is what? That will be 3 upon 4, right? 3 upon 4. Because what extra can be there? BB can be the extra one, right? And what is that? F intersection E is what? 1 upon 3. Out of this 3, how many is GG? So 1 upon 3. Sorry, 1 upon 3 or 1 upon 4? 1 upon 4, right?
Yeah,
1
1
upon
upon
4.
4 by 3 by 4.
3 by 4. It should be 1 upon 3. Clear?
Yes. Yes.
Okay. Do you want to solve a difficult one? Or else let's move to the activity. I'll just
Yeah,
try
we'll
to
try
finish.
one.
Okay, then try it out. One, I'll give you one question. So this question is okay. So consider there's a class having 15 students. Okay. And out of these 15 students, just for example, 4 are from some state S1, 8 are from some state 2, 3 are from state 3, how many? 5, 3, 11, 4, 15. Okay. And 3 students, so 3 students are chosen randomly, one after the other. Okay, one after the other. What is the probability that the selected 3 are from state 1, 3, and 1 again? So, what is the probability that
Three one.
the selected 3 are from S1, S3, and S1.
In this sequence only, right?
Yeah, in this sequence only.
One by 48.
1 by 48. It's not correct.
So
Because it
4
should be
by
some.
15 into 3 by 14 into 3 by 13.
Can you tell me again?
4 by 15 into 3 by 14 into 3 by 13.
That's correct. How did you solve
Yes,
that?
sir. I'm all. Yes, sir. Yes, I'm all seeing same.
How did you solve that? Can you tell me?
Sir, from state 1, the number of probability of selecting a student is 3 by 15. 4 by 15, sorry.
4 by 15. Okay.
Yeah.
Then
we have already selected one student, so total will reduce to 14. And from a state 3, we can still select 3 students.
Correct.
Again, we have selected one, the total will reduce to 13. And from a state 1, as one student is already selected, we are remaining student. Yes, sir?
Correct.
Yeah.
Correct. Yeah, this is correct. So what I was trying to say from the last 2-3 questions that we have solved, even though
Sir,
this is
can't
given
we
as
use
conditional
combination, sir?
probability, you can use everything. Like combination. So how will you use combination?
4C1 into 8C1 into 3C1 whole divided by 15C3.
15C3.
I think we
That
have to
gives
use
96.
permutation here, not
No, but here
combination.
we are
Because we
arranging a
have order.
sequence now.
No. The sequence is fixed. Okay. So the
Acha, so
second
we just have to choose for these sequence.
Yeah,
but
it gives us 96 by 455. Is the answer
96.
coming to someone else? 96
No,
by
no,
455.
no, that's incorrect. Your answer should be something, see, 15, 14, 13. I guess that is fine. What's the value of this? 3? This is 12 into 3, 6, 36, right? And this is 455 into 6. So this should be 6 upon 455. This should be correct. This is 4. Okay.
We can use combination.
Combination you can use it. Okay. So if
Yeah.
you try to, how will you use that? So the
Yeah,
denominator
so
part is
it's like
fine.
4C1 into 3C1
Into
into
3C1 into
3C1.
8C1 whole divided by 15C3.
So why are you getting 96 in the numerator?
4C1 is 4, 8C1 is 8,
Yeah.
3C1
No,
is
no, no.
3.
Why
This
are
is a
you
4
taking
into
combination
8?
is
No, no, 8 you don't have to
combination
take,
is
right?
state 1, state 3, state 1, not state
Yeah.
2.
Yeah, this is not 2, this is
Oh,
3.
sorry.
Actually, through
My bad.
combination, I think the correct idea is 4C2 into 3C1 divided by 15C3. Correct?
Yeah, correct.
That is also correct, right? But if you're taking 4C2, right? If you're just choosing.
Yeah, 4C2
Then
into
also it's not
3C1.
coming same. It will come 6 into 3, not 4 into 3 into 3.
So 4C1 into 3C1 into 3C1. That gives the correct answer.
No, no, that also will give 4 into 4 into 3.
Okay.
Because you're
No,
choosing
no.
a state 1, 2.
4C1 into 3C1 into 3C1,
Into
na?
3C1.
Because
Correct.
state
Yeah,
1 से
that
दो
gives
ले
Yeah,
answer.
that's why.
that you have to do.
Because if you're choosing 4C2, that
Yeah,
means you're not
we have
fixing the
already
thing,
choose
right?
from the state 1 now. Though there
You're
are
just
only 3
choosing 2 things.
remaining.
Correct. So you're not, if you're using 4C2, right? So you'll have to use it every time 3C1 and then 4C1 here and 6C1. Correct? Because if you're directly choosing 4C2 now, I guess if you choose 4C2, the problem that I can think of is the arrangement won't be correct.
Yeah,
You're just
it
choosing
won't be in
2 things.
sequence.
You're not be. But if you're choosing something like 4C1 and then 3C1 and then 3C1, then the sequence at least is correct. That's why you'll be getting the correct answer. Sequence that means this is from state 1, this is from 3, and this is from first state. But here, what is happening is 4C2, you're not directly choosing that 2 people are from state 1. But that can be 1, 1, right? And this can be 3. But that we don't want.
But if arrangement is taken, then just take 4P2, we will get the answer same 12 only.
4P2.
P2. And then we can have for this as 3P1. Answer will be same only, sir.
However, the denominator part will be a problem then.
Yeah. In denominator.
Okay, so that what here you can do is the same formula 4C1 into 3C1 into 3C1 divided by 15C1 into 14C1 into 13C1 is supposed to take individually, then the answer would be correct. Otherwise, if you are taking whole 15C3, if you are taking as a denominator, you will be again facing the problem.
Correct. So do not what I'll say is to
You can take 15P2, P3,
We can
15P3.
better basic
But
bifurcate
there is no formula.
It's better is to just go with the basic approach, like whatever we have solved it, right?
Yes, sir.
Because whenever, even if you're solving a conditional problem, like, see, mostly I'll tell you, whenever there's a problem from the base theorem, then only you should be using the formula. Other than that, mostly, like, you can use the formula, you'll get the correct answer. But if you just go with the basic approach, I guess most of the time you'll be able to solve it without using the formula. Like, just
Yes,
with
the logic approach.
But the base theorem, for the base theorem also you can solve it, but there the formula you'll have to use at least for the denominator part, just to calculate the total probability of getting some event, right? That event is coming from some n number of like things, right? Okay. So shall we move to the next part? Okay, yeah, go ahead.
So combination is more complex than basics.
Combination is?
It is more complex than basics. We can use basics for either complex.
So that is what combination and all is like if you have been given directly the question from the formula, like you have to choose it from this many people. There's not much condition has been given. You can directly use the formula. But if there are so many conditions has been given to you, I don't think so you'll be able to use. You can use it. There's no problem. But there will be like
It will take
something
time.
will be missing, and then you'll be getting the wrong answer. Okay.
I got it.
So next, uh, let's move to the next question now. Okay. So the next question is, I guess we have solved it. There's again the similar type of problem. If you want to solve it, you can solve it. The question is, consider that you have a box with is 5 blue, then 3 red, 4 yellow marbles or ball, whatever you want to call it as. You are going to put out one marble, record its color, and put it back in the box. So basically, you're doing subtraction of one marble, 1 minus 1. But again, you're putting it back. You're recording the color. Color here. Okay, I'll have to write it, otherwise you'll get confused, I guess. I'll just write it out. This question. So a box contains 5 blue, 3 red, and 4 yellow marbles. So basically, we are going to pull one marble, record the color, put it back in box, and again draw another marble. The question is, what is the probability of pulling out a blue marble followed by a yellow marble? So
So
probability
5
of
by 12 into 4 by 12.
So it's yellow, red. It's yellow, yeah, red.
no, pulling out a blue marble followed by a yellow marble.
So 5 by 12 into 4 by 11.
It's
But
repetition
we are
allowed or
putting
not?
it back, right?
5 by
It's
12 into
repetition.
4 by 12.
It's repetition allowed or not?
5 by 12 into 4 by 12.
Repetition
No,
allowed or not?
4 by 11.
Repetition is allowed because you're
No,
putting it back into
look,
box,
Repetition is
look,
right?
look.
allowed.
Put it
Look,
back into
look.
The ball is
box.
put in back. No.
Okay, look,
5 by
listen.
36. It's 5 by 36.
Listen, listen.
sir.
Are listen. Hello, listen. If you will shout like this, the answers and everything, how is sir gonna explain? First, listen what sir is saying, then you will come to the conclusion.
No problem, no problem. So just tell me, how did you solve one of you? How did you solve that?
So
So
first
there are
So the
5 blue marbles.
there is the probability of getting this is what has been asked. Okay. So now, how will you calculate? The first is blue ball. What is the probability of getting a blue ball?
5 by 12.
5 by 12.
5 by 12. Now the next part is yellow. What is the probability of getting a yellow ball?
4 by
4 by
12.
12.
4 by 12.
This would be a correct answer. Because
Yes.
you have been, because the repetition is allowed here. It has been clearly mentioned, even though if it was not mentioned, if it was just mentioned as the repetition, like not, they will not be mentioning the repetition is allowed. They'll be just asking you the replacement is allowed. Means you are just taking out the ball, record it, again you are putting in the box. You're not pulling out. Okay, so that's why it should be a correct answer. But 1 upon 3. So this should be 5 upon 36. Is it clear to everyone? So this type of problem is very highly prone to be asked in the exam also. So this box, color, all those stuffs will be asked in the exam also. And this whole 5 to 8 is like everything will be from your this type of problem. The whole paper will be like this one, because I guess from 5 to 8 is permutation plus probability itself. Okay, so this type of problem will be there for sure, like 3-4 problems like a ball, marble, all those stuffs.
Okay, sir.
Yeah.
Sir, can you explain the
So next,
multiplication rules? I didn't get it in the dashboard
I'll just
video.
multiplication rule.
Yes, sir.
Okay, I'll just start so multiplication. Sometimes it becomes very easier to work with conditional probability space than the original probability. So okay, I'll just see what is that. What happens is if we have to calculate. So the normal formula is what? The conditional formula is what? A given B is what? Probability of A intersection B upon probability of B. Correct?
Yes, sir.
Hmm?
Yes, sir.
And then if you
Yes,
just
sir.
cross multiply it, probability of A intersection B is what? Probability of B times probability of A given B. This is what we call, so for n number of event also, like for example, probability of A1 intersection A2 till AN. How can you write it? Probability of A1 times probability of what? A2 given A1 times probability of A3
J given
given A1
A1
intersection
intersection
of
A2.
A2. Yeah. So see, whatever we have solved it, all we were using the same concepts, but we were not writing the formula. This is what I'm saying. So you can use the formula also, but to use the formula, first of all, you have to define all the events. Like you'll have to define the event A1. So we are doing the same stuff. Okay, I'll just solve the same problem, similar type of problem. Okay, let's solve one problem. Same, the questions are there, right? State 1, state 2, state 3. Let's try to solve it this method approach. This approach. Okay, how will you solve that? So there was a question, 15 students were there, and out of that, 4 is from state 1, and see how complex this will become if you are just using trying to use this formula. Is 2, and then the remaining, the third one was what? How many is 3? Now you have been asked to calculate 3. What was the probability? What is the probability that the selected 3 people are S1, S3, and S1 again. Now let's start defining the events. If we'll just define it, let's for example, A1 will be what? That people, because you have to calculate what? Probability such that A1 intersection A2 intersection A3. This is what you have to calculate, correct? And you'll have to define something. So the A1 should be what? Can somebody tell me? The first person, the first student.
4 by 15.
4.
No, that is fine. I am just defining the event. State 1. A2 will be what? The second student should be
Should
from
be from student
State
state
3.
student state,
state
and
state
third
3.
is from
State 1.
State 1.
state 1. Correct? Now we'll use a formula. What is the probability such that A1 intersection A2 intersection A3? This is what I have to calculate if you are using the multiplication rule. We have solved it with the multiplication rule only, but we haven't explicitly defined everything and all. And then, but if you just try to solve it, what is the probability of A1? 4 upon 15, correct?
4. Yes.
What is the probability that
Yes,
the
sir.
first student is from state 1? That is 4 upon 15. And now, so this formula should be what? How will you write this? Probability of what? A1.
A1. Probability
Okay.
of A2
Let's
given
calculate
A1.
one more thing. Probability of A2 given A1. Now what should
Yes.
be the value? This should be what? A1 given that the first is done, right? Now you'll have to choose A2 regarding the A2. So 3 upon 14, correct?
3 upon 14, yes.
Right?
Yes.
Is it clear
Yes.
to everyone? And what
Yes.
about the third part would be what?
Not clear, sir.
No. So the given the first student has been selected from the state 1, correct?
So P A2 by A1 कैसे निकला मतलब P A2 intersection A1 तो नहीं दिया हुआ है ना बात ये है
नहीं दिया हुआ है that like I'm just asking you the probability of A1 is what? Probability of A1 to get the probability of A1 this 4 by 15 that is clear 15 स्टूडेंट्स में से 4 स्टेट 1 से है तो पहला अगर सेलेक्ट करना 4/15 नाउ द सेकंड अगर एक ऑलरेडी सेलेक्टेड है A1 सेलेक्ट हो गया नाउ यू हैव टू सेलेक्ट व्हाट A2 given that
yes,
the A so the what should be the probability of A2 the second student from S3 given that will be from 3/14 correct because it is given that one student of state 1 is already selected right so that's why this is 15 like 15 minus 1 14 correct see A1 does A1 making any like A1 select ho gaya but probability of A2 given A1 that is not going to make any difference it will just change the number of the total number of students because एक तो select हो गया one is already been selected so that's why the denominator part will be 15 minus 1 14 clear
yes sir
now the next part should be what probability of what A3 because the formula mein kya you have to calculate this also right so
sorry sir
what is this
I don't speak in Hindi
oh, no problem I'll not be talking in Hindi so A3 given A1 intersection A2
intersection A2
what is this value
A3 is equals to it's
3/13
3/13 upon A1 intersection A2 is
that is 3/13 right
yeah
why its
because it is
A3
given,
value is 3/13 now
because it is given that one from each state 1 and 3 is already been selected so the number has reduced to 13 correct or not
yes sir but I mean question is it's A1 intersection A2 दिया नहीं यहाँ पे it's not given this in the question A3 is equals to 3/13 now
A3
it's A3 is equal to 3/13 because S3 is equals to is 3 and दो पहले select हो चुका है 15 minus 2 is equal to 13 3/13 हुआ ना
see I'll just 3/13 is correct only 3/13 what's the issue no can you repeat it like
You
maybe
are confused that A1 intersection A2 means this condition is already happened, not means the question will be given the value A1 intersection A2 always.
I guess yeah correct
This condition is already happened. You have
So
to
we are
consider it after
yes.
after that you will calculate the value
Yeah.
of A3.
So A3
That's
is the
why
total condition. From that we minus the condition that has happened, and that remains the for just A3, last one
right.
selection of
Yeah.
from S1.
This is
He
not
is
the
searching for the value. He's
no,
searching for the value.
no I understand value will not be given every time if you have been calculating probability of A given B and then if the this probability of A intersection B has been given to you and then probability of B has been given to you then you can calculate it but here the scenario is different right here the scenario is like the given that A1 has been selected already and then you have to select A2 A1 intersection A2 so both has been selected already now you have to select A2 so that every time so that's why I was not using this formula this formula will make you more confused like and we were not using the formula we were able to understand it nicely right so the same thing if you just define the events and then solve it you'll get confused so it's better to not use the formula every like at least this formula is I don't think so this will you're doing the same thing but without using formula you're able to understand it nicely correct
yes
can you explain this question again बहुत confusion हो गया
okay so okay without this everything I'll just explain you without using this formula and also the question was pretty simple the question was there were some 15 students and out of the 15 students 4 is from some state 1 8 is from state 2 3 is from state 3 you just have to calculate the probability such that The first people that I selected is from state 1, the second one is from third state, and the third again is from state 1. Okay, you have to select it. So just think of this. First is from state 1, second from state 3, and third is also from. So if you have to select the people from state 1, what's the probability of that?
Yes, sir.
If you have to select the people, okay, that should be from state 1. What is the probability out of this 15 people? How many are from state 1?
4 by 15.
4 by 15. Clear? Now it has been selected. Now, okay, this has been done, right? A1 is done, right? The first thing is done. Now you have to select the second people should be from state 2. What is the probability of that? One people is already selected, right? Out of this 15, one is selected. The denominator part will be 14 for sure, right?
14.
Okay. And now,
three
what's about the
14?
3 by 14?
Correct.
This is what we were doing, right? Correct. This is what we were doing. A1 is selected already. And now you have to select A2. A2 is what condition? That the second student will be from student S3, state 3. This is what has been given, right? This is what we have calculated using a formula. Here also we are doing the same thing. Here what we are doing? Probability of A1 intersection A2 intersection A3. A3. A1 is what? The first student is from state 1, second is from state 3, third is from state. This is what we are doing the intersection. This is a multiplication rule. And this is what probability of A1 we are doing, then A2 given A1, and then probability of A3 given A1 intersection of A2. The third condition is what? A1 and A3 are selected. Now you have to select one people from state 1. Okay. And out of that, how many people are left now? 13 are left, right? 2 people have been selected, right? How many are left? 13.
3 by 13.
And how many are there in state 1 left? 4 was there in the starting. 1 is left. 3. This is correct. This is the answer, right? Done? It's clear, right? Now?
सर बस हमको यहाँ कंफ्यूजन हो रहा था A2 by A1 था 3 by 14 गया था बस समझ गए मतलब A1 को तुम बता देना ना.
Now you have understood, right? No.
तो जो A2 by A1 था वो 3 by 14 ये से हो गया ना.
No. Okay.
But it's a simple notation. Don't get confused in this.
Practice assignment.
Okay. So A1 is then selected. What's the probability of getting A2? So A1 is the event is what? A2 is an event and has been defined such that A2 is an event such that the second student is from S3, and A1 is an event such that the first student selected is from a state 1. Yeah.
Sir, I think sir is not understanding the notation that you are using over there. The permutation part and the bracket A2 slash A1. He's not able to understand what that means. So actually he's getting confused.
Can you attended the classes?
I think
due to high fever सर मैं join नहीं कर पाया था और ये जो था
So that's why you are confused in this.
He's not able to understand the notations only, sir.
Yes.
Always getting confused.
Please complete the class.
Sir,
Okay.
hello.
Okay. So whoever was having a doubt, right? You can just what you can do is you can just put.
Sir, mute.
You can just ping me, okay? Maybe on the mail or somewhere. I'll try to do it later.
Sir,
But now,
just a small thing in this. I referred to this question, but the thing is that in this question, in that particular PDF, the multiplication rule is used twice, right? So in the later part, I have not understood that have been done. So it's like probability of A1 multiplied by probability of A2 intersection A3 given that A1. So they have considered A1 as B. Sir, the later part of this. So probability of A1 intersection A2 intersection A3, right? So this they have considered it as probability of B intersection A. So here, just a minute. A1 intersection A2, A3. Yeah, the empty space would be A3. Hello, am I audible?
Yeah, you're audible, but I'm what you're trying to say is
Yeah, the question you are referring, there's the same question in PDF. The later part, if you refer, can you please explain that? That would be great. So my queries for this question would be at least over for one side now.
No, if you have been asked to calculate probability of A1 intersection A2 intersection A3, correct?
Yes, yes.
Correct?
You are going
Yeah.
correct.
So probability of, this is what the formula is, what probability of A1 into probability of A2 given A1, correct? Right?
Sir, they
It's
have
not correct.
considered A1 as is equal to B and A2 intersection A3 as A. So it becomes
No,
B intersection A.
no.
So because of the notation they have considered in the PDF, I'm getting confused. Yeah, you can continue solve this so I can get a new perspective as well.
So this is like we have already solved, right? This you can take A, B, C, anything, but this is what it should be at the end. Sorry, A2. This is a formula like the multiplicity wala formula, right? This is what we use it. Correct?
Sir, this question
So
is
in
of the
this,
statistics textbook, and in that book they did it differently.
okay. Okay,
Please
so
share the screenshot so that you can understand.
Yeah, share the screenshot. Sir, till then, sir, continue. Just continue for activity.
okay. Let's move to the.
So let us continue, please.
Okay. You can just send me this screenshot maybe on. You can just send me on my mail ID also. So basically, at visal@study.itm.ac.in. Okay. Or maybe on the discourse you can tag me. Like give me the send me the screenshot regarding that.
No, can you share that email ID in the chat?
Yeah. Just share it out here. One second. Yeah. So I've shared my mail. So just like you can just send me the screenshot. Not please don't spam there, but yeah, you can just share me the screenshot regarding. Okay, let's move to the next part now. You can share your doubts also. Yeah. So if you have a doubt, first you can just put it on the Discord. There, if you're not getting there are people who usually solve your doubt on the Discord also. You can tag me also there. But if you're not, yeah. Okay, let's move to the next part now. 8.3 is been done. Let's move to 8.4 now.
CET. Germany over
8.4, I guess all the questions are pretty simple. So can we skip this? There is nothing. So it's all
Yes, please
simple.
skip it.
Yeah, we are all simple. 8.5 now. Okay. So the first question, 8.5, if you have the question in front of you, the question is given here. Suppose that we roll a dice, and so each of the 36 outcome is equally likely. Fine. We roll a pair of a dice. Okay. So that's why we are getting a 36 outcome. Let A denotes the event that the first die lands on 5. Okay. So A denotes that the first die is 5. And B denotes BBA event such that a sum of the rolling sum of, so can you please mute yourself? Sum of the outcomes of the rolling the pair of a dice is, so basically x plus x1 plus x2 that you are getting is 10. Then C is a event. So the sum of the outcome of rolling the pair of a dice is 7. Okay, so sum is 7. Here x1 plus x2 is 7. And here it can be anything. It's a blank box. Now it has been asked which of the following is correct. So basically you have to calculate the probability, right? And then we'll have to check. We'll have to check for the independent, right? For independent, what's the condition? Probability of what?
x1 plus x, sir, it's x1 plus x2 is equal to 10 आना चाहिए ना, x1 दिया हुआ है.
For the second condition, for the second event, it should be x1 plus x2 should be 10. So whatever the x1 and x2 that you have to check out, like how many values, which are the values out of this 36 outcome can be in the B event. Similarly, for C, you have to check it. How many of them are in the C? Okay, and now for the independence, what will you check? What are the conditions to check for the independence? A intersection B should be what?
A into B,
A
probability A into B.
A into probability of B.
B, yeah.
And similarly for BC, you can check it. But yeah, can you tell me what are the conditions? What are the all events favorable event for A, samples for A?
So what's the condition? 5 and
No, the first thing, yeah. So basically, it should be 6 values, right?
6 values.
So the first term is the first die lands on 5. The other can be anything, right? Can be 1, 2, 3, 4, 5.
6 by 1 by 6, sir.
Okay. What about the B?
It's 3 by 36 got 1 by 12.
No, what are the outcomes? So here it is 5, 1.
It's 4, 6 and 6, 4.
5, 2, 5, 3, 5, 4. This question is not been discussed, or this is discussed already? Okay, this is A, right? Now we have to discuss B. What are the
4, 6, 6, 4, and 5, 5.
4,
6, 4 and 5, 5. And 5, 5.
5, what about C?
1, 6.
It's
6,
1,
1.
6, 4, 3.
3, 4.
Just
4,
go
3.
in
3,
sequence.
4.
2, 5, 5, 2. Then 3, 4.
Yes, sir. 5,
4,
2.
3.
4.
हो गया. 4, 3.
Done. All are there.
Yeah, yes, sir. Done. 1 by 6.
Okay. Now calculated. What is the probability of A?
1 by
1 by 6.
Probability of A.
Yes.
Probability of B.
1 by 12.
Okay. And what is A intersection? A intersection B is what?
5, 5. So 1 by 36.
1 by 36. Is it equal?
No, they are dependent.
No. Correct. What about the second case? Second condition is what? A and C has been asked, right? A intersection C. What is probability of A?
1
A
by
is
6.
1 upon 6 and C is also 1 upon 6. And this is
1 by
A
36.
intersection C.
5,
What is the
2. 5, 2. So
5,
1 by 36.
5, 2 is common. Okay. So this is
So they are independent.
Is it clear?
Yes.
No. Now the second question is, okay, so the second question is, suppose that we are going to roll 2 fair dice, 2 fair 4-sided dice. Okay, what is the probability that both sides show 2? What is the probability that this will be 2 and this will be 2? What will be the probability?
1/16.
1/4 into 1/4. Correct? Any doubt, anyone? I guess these are very simple questions. The third one is the probability of a flight being delayed. Okay. What is the probability of no delay on a round trip? Okay. So on a round trip, no delay so it should be no delay in going and coming back also no delay. What do you think? What should be the probability? So in coming back also it should be no delay.
0.36.
So this should be what? While going also no delay means 0.6.
Why, sir?
And 0.6 while coming. Yeah. So
Why
going.
the
So this is the given information. Okay. Probability of a flight being delayed. So delay is what? 0.4. So probability that flight will not be delayed is what? Not delayed is 1 minus 0.4. So that is 0.6. Correct?
Yes, sir.
And now it has been said that it is on a round trip. That means it goes from Patna to some Bangalore and then again from Bangalore to Patna. Okay, so there also no delay while going from Patna to Bangalore, and again coming back also there is no delay. Okay, so what is the probability of occurring that? So if it is going from some P to B, 0.6, and again coming back is 0.6. So that's right.
Yes, sir. It's
Clear?
0.36.
A dice has been thrown thrice. What is the probability of outcome of a prime number? This is simple. It's no doubt.
Yeah.
This is simple. So let's move to 8.6 now. Okay. So 8.6, okay, I guess 8.6 question of 4. If we have an A, B, C, be pre-event, and it has been given that probability of A intersection B intersection C is equals to probability of A intersection. It's given that probability of A multiplication of probability of B multiplication of probability of C. Is this a independent event?
Yes, sir.
No.
Yes.
How, like, it is not an independent one. Why?
You can do some example and it will not come true.
Or see, for the independence of three like events, right? You'll have to individually also it should be independent. Okay, are you getting me? Then only it will be independent. That means the probability of A intersection, all this should be true. So all those combination you can just make it. All those should be independent. Okay, is it clear?
So it's like
Yes,
not
sir.
always independent. Maybe or may
Uh,
not be independent. It
yeah,
depends
it
on the
can.
question, right?
Yeah, see,
So, sir,
mathematically there can be sometime like mathematically it is equal. Are you getting me? Like, see, there can be an exception where mathematically it is equal.
Got it.
In those cases, it is independent, but to check it, you'll have to check for all the other cases also. For a,
even for one example, if the condition does not satisfy, then we say the statement is false, right?
yeah, correct. Even for a one statement, it's not correct. That statement is a false.
Can you explain this question again?
No, what I was trying to say is to determine that ABC is an independent event. All the conditions should be satisfied. All the other conditions should be satisfied. Okay, like C, probability of B intersection C. This also should be equal to probability of B into probability of C. Similarly, probability of C intersection A. This should also be probability of C multiplication of probability of A. This three condition plus this condition. If all those four conditions are satisfying, then we can say that all the three are independent to each other. Okay.
Yes, sir. Hello.
Yeah.
Yes, sir.
Yeah.
P intersection B is equal to होता है PA into PB, मतलब probability of A into probability of B. P
No,
intersection
it's
A
not
intersection
always
B.
true. Or if this all condition is satisfied, then you can say that all the three events are independent. This is not like it's always if this is satisfying, that means you can say that it is an independent event. A and B. If A intersection B is this one, you can say that these are independent events. Okay.
What are the conditions? Can you explain? Yes, sir.
What?
Can you explain, sir? What's the condition? Then he is correct. Can explain, please.
It depends on the example. You take any example and then you try to adjust the given statement.
Yeah. What did you say?
It depends on the example.
Okay, I will see the video later.
No. See, independent event. You are not. Are you asking independent event or something else?
It's independent event.
If you're like independent.
Basically, sir, he's asking what example of which makes this statement false.
Oh, make this statement false. The
Yes.
statement is already false. If you have been given A, B, C, this is false only.
Okay, then.
No, what I would try see if you have been just given that probability to make if you have been given something like that, A intersection B is probability of A multiplied. So if this has been given, again, why are we how are we able to write this? Can somebody tell me how are we able to write this? Let's for example, if you have been given A given B, this is equals to what? Probability of B, probability of A intersection B, correct?
B intersection B. Yes, sir.
See, if the event is independent, so occurring of B before A, that does that make any difference? If A and B are totally independent to each other, so probability of occurring of A has not been impacted by B, right? So this will be what? Probability of A itself, correct? So that's why you can write it like this: probability of A into probability of B is equals to probability of A intersection B. Okay. And if this is occurring, that means you can directly say that both the event are independent because you have replaced A given B as A. Okay.
Yes, sir.
Oh, okay.
Yeah. Now I guess let's move to the base theorem. We'll discuss some questions of base theorem. I guess this is done.
8.7.
8.7.
Sir, I have one request. सर जब पी ए बाई बी वाला था ना, क्या उसको लास्ट में एक बार समझा देंगे सब कुछ खत्म हो जाए क्लासेस तब.
And try to speak in English
सर
because most. Yeah. So what I was trying to say, this one you're asking, right? Probability of A given B, how this becomes probability of B? Sorry, probability of A.
मैंने बहुत ज्यादा मतलब वेदर चेंज तो मेरा तबीयत बहुत ज्यादा खराब हो गया, तो मेरा बैकलॉग ज्यादा हो गया.
No problem. You can just mail me. Okay, I'll take some extra session for you. Okay. Okay, you can just mail me because this time we are already short of time, so you can just mail me. I gave you the mail ID, right? You can just ping me there. Okay. Maybe there are TS there. So there are some TS session also. There are 4-5 TS session that occurs like regularly, weekly, right? So I'll just assign someone. Just okay. So let's move to the next part now. So base theorem, right? Base theorem. So there is a first question that has been given here. So base theorem mostly will have to use the formula because at least for the denominator part, wherever there can be some sample space, collection of events, probability function, all those things can be given to you. Okay, let's start with one question itself, then maybe that will clarify your doubts. So the first question is what? So here, so this is a question. So there are basically the first question is to earn or maybe box you can just think of. A and B is being given to you that contains, maybe this is a box A and this is a box B that contains 7 red balls and 6 blue balls. And here it is 5 red ball and 8 blue ball. Okay. And the question is, if an box is chosen at randomly, so probability of choosing box A. So if, let's for example, if somebody has to take out some ball, so first what he'll do, first he'll select a box, right? From which box I have to select a ball, correct or not? So choosing a box is on the probability is 0.5 and 0.5. Choosing a box, if I have to choose a box, the probability of choosing a box itself is 0.5, and then only I can go and take out some ball. Now it has been asked that if a drawn, then a ball has been drawn at random from a chosen ball box. Okay, let's for example, a ball is drawn from the chosen box. Then find the probability that a red ball is drawn. So you have to just think of this concept of what? Law of total probability. That how can you can get a red ball, right? So basically you have to calculate the probability of R. So you have a bigger sample space. You have divided that into B1 and B2.
It's sir.
So red. So let's for example, this is a sample space for getting a red ball. 1 second, just give me one. So this is a sample space for getting a red ball, and there can be this box can be B1 and B2, right? So how can you get a red ball? So this you can get it from B1 or you can get it from B2. There's nothing else, right? If you have been given 3 boxes, let's for example, this 3 boxes, and this was B1, B2, B3, then red ball can be coming from B1, B2, B3. So all together we have to add it, right? So red ball for our case, it can come from either A or B, correct? What can be the formula? What will be writing? So first case is you'll be getting from A, second is you'll be getting from B. Can you tell me the formula? How will you write that?
सर अलग-अलग निकाले तो उससे फॉर्मूला था ना.
So this can be the probability of getting red ball given from where? From A box. Given, see, I'll tell you one thing. So here also, if you don't know the formula, you can. So probability of getting, you'll have to get a red ball, right? How can you get a red ball? What should be the first step? First choose a box. First you have to choose a box, right?
Either it will be from A or B.
Correct.
So
So if
7
you're
by
choosing a box,
13
correct.
plus
Like
5 by
6 by
13 and divide by 2.
Yeah.
The whole thing.
Correct. I guess 6 by 13 or okay,
It's
but
12 by
I'll tell you the
58.
okay, no problem. I'll just tell you the procedure and then you can give me the answer. Okay. So to get a red ball, so this is basically the law of total probability. Law of total probability to get a red ball. You have been given some 2 box. You can be given some n box also. The first I have to choose the first box. So choosing a first box, what is the probability? 1/2. Correct? Right? Now, if you have chosen the first box, what is the probability that you will be getting a red ball from the first box? Because now you have chosen the first box. So this is what, see, this is what you write. First you choose a box. So this is PB1, or you can say the box 1, right? So probability of choosing a box 1 is 1/2. Now you are going inside a box 1. In this box 1, what is the probability that getting a red ball? What is the probability? 7/13, correct?
Yes, sir.
So this is what?
Yes,
This
sir.
is probability of getting a red ball given this is a B1. Correct? Now addition of this. And again now you will choose box 2 because box 2 is left. So 1/2. This is what? Probability of choosing box 2. Now you are going inside a box 2 and then you are choosing a red ball. How many balls are there? Red balls 5.
5 by 13.
5/30.
5
So
by
this is what?
13.
Probability of red given this is a B2. Now tell me how many of you are able to understand this. This clear or not?
Yes, clear.
Yes, sir.
Yes, sir. Clear.
Yes.
Right, and this is the formula, right? This is the formula for this your law of total probability, right? Like if you have a sample space, bigger sample space, right? And then if you are just dividing this into some 5, 10, B1, B2, B3, B4, something like that, and then you have to calculate the probability of getting something, right? Let's for example getting A. This is A for you. Probability of getting A. How will you get it? Probability of getting A is what? Probability of A given B1. First you went to the B1 and then A out of that. Again probability of getting B2 because you went to the B2 now, and in this B2 you have some A, right? So probability of A given B2. Similarly, probability of choosing Bn multiplication of probability of A given Bn. This is what the law of total probability. Is it clear? Yeah, right? Let's move to the next question. Can you move to the next question?
Yes, sir.
Yes, sir.
Yeah. Yes, sir.
Okay, so we can solve one question again on the law of total probability. So the given question is, again, this is a person has a 5 coin, and out of this 5 coin, he has 2 coins are double headed. One is double tailed. One coin is, and 2 coins are normal. This you are able to understand this? 2 coins
Yes,
are double
sir.
headed means both the sides is head. Okay. Now he picks a coin at random and tosses it. So now let's for example you out of this you just choose a coin at random. Choosing at random, that means what? What is the probability of choosing any one like coin?
1/3.
And what is now you have been asked that he picks a coin at random and tosses it. What is the probability that he'll see a head? Probability of head. What
1/3
should be the
into
value?
2/5. 1/3 into
1 by 3 why?
2/5.
1 by 3 no 1 by 3 why? 1 by 5, right? You have 5 coins, right?
Yes.
Yeah, 1 by.
Now tell me probability of getting a head.
Oh,
So
sir,
that head
I do
can.
not understand this double-headed.
Sir, can we say 1 minus 1 by 5?
Okay, so basically you have 5 coins, right? Coin 1, coin 2, coin 3, coin 4, and coin 5. For coin 1, let's for example, both the side it is head. For coin 2 also both the side is head. There is no tail. Again for the
Acha,
third
acha,
coin, this is both the side it is tail, no head. But for 6 C4 and C5 it is both are normal. One is head, one is tail. Okay, got it,
Okay.
right? Now
Yeah,
choosing
yeah, got it.
out of this 5, choosing a coin is random. Like all the probability is 1 upon 5. Now you have to tell me what is the probability of getting a head. How can you get head? You can get head from how many? Can you tell me from how many coin you can get a head? From 4
Double
coin you
head
can
and
get a
2
head.
are normals. 4/5.
Yeah.
Yeah,
So this is
1
the
plus
same case,
1
right?
plus 0 plus half.
No, 1 plus 1 you can't do, right? Like
What?
1 into
They're
1.
double
How?
headed, so it will be hidden every time. Means I have to put 1/5 as common.
Correct. 1 by 5 you have to take it as a common. So first you can just think of it is coming from here. C1. C1 is double header. You can just, I will write it as like this. This is tail, this is head tail, and this is head tail. So first it is coming from C1. So if this is coming from C1 means 1 upon 5 into 1, correct? If this is coming from C2, 1 by 5 into 1. Because first you have to choose C1, right? If you have chosen C1, then the probability of getting a, see this is what, this is probability of choosing C1. This is what probability of, can somebody tell me what is this? What is this? What is the value? This 1 is what? Probability of what?
Of head.
Probability of getting a head.
Head. Probability of getting a head given C1.
From C1.
Given
From
C1.
C1.
Then only you'll be getting, because both are headed, right? If you are tossing, you'll get a head every time. Because it's a double header, right? Both the side are headed. Correct? Similarly, for this case, probability of this is C2. And this is what? Probability of head given C2. Similarly, for this case, it will be 0, right? 1 upon 5 into 0. Because probability of getting a head given this is C3, this is 0, right? Because both the side it is tail. Is it clear or not?
Yes, sir.
Yes,
sir.
it's clear.
Similarly, for C4, now you have to first choose C4. So
So
basically,
can you please
C4.
repeat that once?
Okay, I'll just repeat it. Okay. So what I was saying is, the question given was there was 5 coin was given to you. 2 coin for 2 coins are biased. Biased means both the side are head only. Okay, if there's a cricket match, if
Okay, sir.
somebody tosses a coin, he'll get the head always. There's no tail. For 2 coins, both the sides are head only. For 1 coin, both the sides are tail only. But for 2 coins, there is normal coin that we use in like normal condition. So 2 coins are normal. Other 3 conditions, 3 coins are abnormal. They're not normal. Okay. Now you have to calculate if you are tossing, what is the probability that you'll be getting a head? So to get it, so there are 5 coins, right? From 5 coins, you'll be able to get it head. If you have a 5 normal coins, let's for example, you'll be getting a head from all those 5, right? But here,
Hello.
Hello.
Yeah.
सर को लगता है आई पर अटक गया.
You are not audible.
We are going. एयरपोर्ट वैसे भी डिस्चार्ज दिख रहा था ऊपर में 20%. ऑब्वियसली चार्ज लगाने गए होंगे.
yeah. So sorry for that. Again, I got disconnected somehow.
No.
So I don't know. My tab is hanging again. Okay, I'll just share my screen again.
So do we have a quiz to model question paper revision session?
Yeah, that'll happen. That'll
And when
happen next
it's
week.
not showing in the calendar.
Okay, for stats one, I'll have to check. Yeah, and for maths one, it has been scheduled. For stats one, I'll have to check it.
It's showing on Tuesday, 6 to 8. It's showing, but it is going to done by Professor Usha ma'am. Yes.
Yeah.
That is
So
that session or else?
That will be a revision session, but there will be one more regarding the mock.
So will it be plot the session hereafter?
Hereafter mock session.
Yeah.
Yeah, that will be scheduled, I guess. I'll talk and then that will be scheduled by tomorrow, Monday. Yeah, tomorrow it will be scheduled.
Okay,
and
please do
for
that.
math session, we don't have a math session today because the person who was about to take is not well, so she'll be
So
taking the session,
class
I
is
guess.
completed.
No,
The class is completed.
no, not this one, not completed. I have to discuss
Because
some
sir,
more questions.
math English class है.
No, maths. This is what I'm saying. Maths session is been rescheduled to tomorrow because it was a Sunday today, so that's why we were not able to send you the mail. Okay.
No
Like,
sir, it's not a math. It's an English class.
Oh, English class. Okay.
That is read with us.
Yeah,
Oh.
it's read English.
Okay, I'm not
Sir,
aware
in
of.
calendar, it is now
Even
showing
7
maths
to
class from 8 to 10 p.m.
It's not showing
today.
if you reload it. If you reload it, it was showing in the morning, but now it's not showing.
Okay,
Yeah, that is
okay.
what I'm saying. It has been rescheduled to tomorrow. Like, continuous will be having some 5 till Friday. We'll be having session of maths, 2-3 revision session and 2 sessions for math and 1 for math. So from tomorrow we'll be having daily 8 to 10 for, I guess,
Sir,
4-5
do you
days.
have any idea about CT syllabus for quiz 2?
CT. I'm sorry, I don't.
Yeah.
Mostly
1 to 8.
Somebody please tell.
Week 1 to 8.
1 to 8, majorly 5 to 6, 5 to 8.
Yeah.
for maths
For
and stats, I can tell you mostly it will be
yes,
from week 5 to 8. Like, even for maths, if you're not going and revising 1 to 4, that is not going to harm you. Even with the concept of week 5 to 8, you'll be able to solve the questions.
okay.
There won't be any core questions from week 1 to 5, like a relation
And
or those type of questions. The
okay.
questions may be like a on to function. Those were there in your week 1 also. That's why we are saying
Yes,
that's
yes.
why we are saying it from week 1 to 8, because sometimes what happens, people generally come up with the question and says that it is from week 1, why have you given? So that's why we have to say that it is from week 1 to 8. Okay.
Yes,
Otherwise,
sir.
you'll not be getting any problem. If you're not revising it also, it's totally fine. Okay.
And what about English?
English and CT,
What?
I don't have any idea.
No, sir. I'm asking. Anyone can tell me.
Okay.
If
I'm not
if
supported
anyone,
in this class.
someone know about.
Vishal, for stats also, 5 to 8 is the
Yeah.
major thing, is it?
Yeah.
So 1 to 4, there won't be any questions, or will there be any questions?
No.
There won't be any questions. Already mail sent.
Yeah, there won't be anything from week.
Why I'm asking this question is because in the mock test, I was able to see 3 questions referring back to variance, standard deviation, and all that. So
Then
will it
there
be the
is no
same?
question. No question. Maybe mock, I don't know how did they give, but there is no question that I can tell.
Got it. Thank you.
Okay. I'm not able to share my screen, so I'll just tell you the last question that I was discussing. Okay, regarding that coin. So I have told them to make me the course till now. One second.
Vishal, just a request from my side. The
Yeah.
last question in that activity was 8.7, no, the 7th question. That's a very tricky for me. I felt it very tricky. If you can, I'm willing to stay back also. Like, if you can address that, it should be
8.7, right?
8.7, 7th one.
Okay. Just so they have not given me the access till now. Let me check it again. Okay, so I'll just wait for some more minutes. Let's see. So
And as you said that you'll be get back about the weekly activity session problem, which is facing by us.
which session?
Sir. Hello.
Okay, peer review session. Yeah.
Peer
Okay,
reviews.
okay,
Yes.
Yeah.
Sir,
That,
hello. I have
yeah,
only one doubt. Can you explain A by B wala? What means something?
What I was trying to say, so you're asking that when does that probability of A given B becomes probability of A? This is what you are asking, right?
Yes, sir.
Huh. So what? So probability
Sir, can
of
you
A
explain in
given
Hindi?
B. Ah.
Sir, can you explain in Hindi, please,
But
sir?
people doesn't
Please.
understand. Many of the people doesn't understand
Sir,
Hindi, right?
only for हम अपॉन मेरा चल रहा है अभी तो सर जा चुके हैं
No, it's not like that. So you can join some, like, that's why I was saying you can just mail me, I'll just connect with you. But I'll try
Shiv
to.
Jain, actually, there's one session that happens completely in Hindi.
Yeah.
Yes, correct.
Correct me if I'm wrong.
Yeah, every
Yes,
week
yes,
there
it
is
is
one
happening.
session.
Check your
Yeah.
calendar, Shiv Jain.
Yes, sir.
Yeah, there is one session that happens in Hindi. So maybe that.
So all of your doubt will be clarified over there.
Very less people are there. You can just come up one-to-one session. Like, it's very less people join, so you can both come there, and then we can discuss it. But I'll try to simplify that. See, the statement was probability of A given B. So that was equals to A, right? So that means what? Let's, for example, I'm just giving you very basic example.
Sir, your screen is not visible to me.
It's not visual because I've not been made yet the host, like. So that's
Okay, sir.
yeah. So I've been disabled from there because it was already 8. So that's why that the person is basically not seeing my message yet. That's why. So I'll just wait for some more time, and otherwise I'll just try to explain it without writing it. So one question that has been asked, I guess the question is related to the IIT Madras, I guess something related to that. Till that time, I'll just give me 1 minute. I'll just. So see, if what happens now, if we have been given some two events, right? If the one event is not dependent on the other event, are you able to hear me?
Yes, sir. Yes, sir. Yes, sir.
Okay.
I'm
So
sorry.
here, yeah. Okay. So what happens here is, if you have some two events, right, and if one event is not dependent on the other events, so do you think the probability will change?
No. Yes, sir.
See, if you have two coin, okay, if you just have a two coin, okay, if you are just tossing a first coin, okay, if whatever you are getting is, will that impact your second coin getting anything on the second coin? No, right?
No.
Okay. So if you have been asked to calculate what is the probability, what is like getting a head on the first coin, okay, it is like whatever you have got on the second coin is not going to impact you, right? So you can directly say it, right? Probability of getting a head on the first coin is same as probability of getting a head on the first coin, given that something else like head has came on the second coin. Correct or not? I'm not able
Yes,
to
sir.
write it, but I'm trying to. So this is what has
Yes,
been
sir.
said. Probability of A given B is what? If this is equal to probability of A, that means the event B is not impacting anything on the A. So that's why the probability of A is equals to probability of A given B, because B is not impacting A. Both are independent. That's why I can directly write it as like that.
Yes, sir.
Clear, right?
I know, sir. I know, sir. Thank you, sir.
Okay. Let's deal with that question. I am not till now I have not been given the access.
Thank you, sir. Thank you, sir.
Okay, now I have been given. Okay.
Bye, sir. Bye, sir.
Okay, bye. So the problem that I was discussing at that time, now I can see my screen, right? Okay, so this is simple, right?
Yes,
so this
sir.
I was
Yes,
just
sir.
saying that how can you get the head? How can you get the head? So you can get the head from C1 or from C2 or from C3 or from C4 or from C5, right? So this is what I was telling. If you have to get a head, first choose a coin. Choosing a coin is what? 1/5. And then if you have chosen the coin, so given that this is a C1, what is the probability that you'll be getting a head? So this is 1, right? Similarly, you can calculate for others. Is it clear? Or do I have to calculate the whole stuff? Not clear?
Can you just
Clear.
repeat again?
Okay. So what? So if you have to get a head, so the same question as earlier. If you have to get a red ball, so what we were doing? First choosing the box, right? First you have to choose a box, then only you can get a ball, right? Correct. So here also, if you have to get a head, first you have to choose a coin, because you have a 5 coin, right? From all those 5
Yes.
coin, you can get a head. So first you have to choose a coin. So you have chosen a C1. For probability of getting a C1 is what? 1/5, because it has been said that it is like you can choose that out of this 5, it's like randomly selected. So the probability of getting any of the coin is 1 upon 5, right?
Yes, and the total probability is 1.
Total probability is 1 for C1 to sit because you have a 5 thing. If you have to choose one of the 5, that is basically 1 upon 5 because both are
Yes.
all are equally likely. So that's why choosing a coin C1 is 1 upon 5. But now you have selected C1. And in this C1, what is the probability of getting a head? Because this is a double header. A head, like both the side is head. So you can't get anything else. So probability of getting a head is what? 1, correct?
1. Yes, that is what I'm saying.
So this is 1. So 1 upon 5 into 1, correct?
Yes.
Now for the C2. For the C2 also, you are already aware that this is also a biased one. Biased one means both the sides are head, correct? So again 1 upon 5 into 1 because again probability of getting head from C2 is 1.
Correct.
And multiplication is 1 upon 5. For C3, it is 1 upon 5, but the probability of getting head from C3 is 0, right? So this is 0. Again,
Yes.
similarly for C4, this is 1 upon 5 multiplication of probability of getting head upon
1 by 2.
C4, 1 by 2, okay? 1 by 2. And similarly for this case also, 1 upon 5 into 1 upon 2, correct?
1 by 2, yes.
So this you can add it, you will get the value of the total probability. Clear?
Yes, it's clear.
Vishal, I want to just ask whether this approach is correct or not. Just can you scroll a little up onto the question? Yeah. So no, the question. Yeah.
Okay, this question, yeah.
No, the same question. Yeah. Okay. So here I'm saying the probability of choosing double head is 2 by 5, and I'm multiplying the probability as 1. So 2 by 5 into 1, tail is 0, and then normal is 2 by 5 into 1 by 2. I'm getting the same answer, but I want to know whether the approach is correct.
Because for this case, your approach, because it was equally likely, right? So that's why you can directly write it as because 1 upon 5 and 1 upon 5 becomes 2 upon 5.
No, I'm saying 2 by 5 is also equally likely. Because of equally likely only, I'm saying 2 by 5 for double headed.
Yeah, because it was 1 upon 5, so you can directly add it. Like it was added and becomes 2 by 5. That is the reason. Yeah. If it was not equally likely, like then you would not have solved in that way. I guess you would have taken individually and then you would have solved. Yeah.
Got it.
So total probability, we are adding each and every the events, right? I mean,
correct. So let's, for example, this is a sample space. This is a sample space. Out of this is B1, B2, this B1, this is B2. And you have to calculate such that getting some smaller event A. So A can come from B1, A can come from B3, A can come from B2, A can come. So the same case, right? You have to get head, right? This is head. Correct? Yeah. And this is head, and head is coming from B1, this is coming from B2, B3, B4. So this is what you have to add. So because you have to add whole case, this is the whole case, right? For A1. So you have to add all those things, small slices, right? So this is the probability of getting a head, like from all those things. Let's discuss our last question. So I guess he was asking about that. What was this question?
Are you asking the question which I refer to?
I have that question. IIT Madras, right? Something.
Yeah, correct. IIT Madras, 40%.
Correct. So suppose that in IIT Madras, 40% of the people are girls, right? Probability of getting girls is for 40%, 0.40. Probability of boy is what? 0.6. What else has been given? It is known that 70% of the boy play cricket. Okay, so probability of playing cricket 0.7. Probability. What is else given? Probability that girls playing cricket is 0.6. What else has been given here? Now play cricket. While 40% of the students play football. Same thing, right? Boy playing football is 0.4, right? Playing what has been given here? Girls playing football is 0.5. Correct? These are all the information being given to you.
Yeah, and there's one more, 33%. That is for who play both, who play football, also play cricket.
So probability that says that somebody plays football has been given, right? This has been given as 0.33. Correct?
How did you frame the last one?
It has been given then, given
Of
that
no. How did you
33%
frame the
of those.
notation? Yeah.
And so, given that 33% of those who play football, so play football, this is given, also play cricket, right? So this is
So shouldn't
cricket
it
and
be C given F? How did you put
no.
C intersection F?
So see, it has been said that given that 33% of those who play football also plays cricket, so he's playing both cricket and football, and given that he plays football also.
Okay.
So this is okay, clear?
Yeah, clear until now.
Okay. Now, what's the next thing? Let me just put my table. Okay. What is the next thing? What you have to calculate? You have to calculate such that a student is randomly chosen. A student is randomly chosen, and it is known that student play cricket. It's known that okay. So you have to basically calculate what? Known that his student is randomly chosen, and it is known that student plays cricket. Then what is the probability that the student? Okay. 1 second. You have to find what you have to choosing. It is
F
known that it
given
plays foot.
C.
F given
F
C. This
given
is what
C.
you have to This is what you have
Yeah.
to calculate.
Correct.
Correct.
Yeah.
Let's start calculate. So if you have to calculate what it should be there in the denominator, from how
KFC.
can he play cricket, like all the conditions. Okay. So this you can calculate it. Next part is what? Next part is what should be there here. It should be probability of C intersection F. Correct. Okay. How calculate this? Probability of playing cricket is what? Either it can be a boy or it can be a girl. So first, so it can be a boy. So this boy give girl given playing football plus this boy playing football. Correct? Up till now, this is clear, right?
Shouldn't be cricket? No, we are calculating cricket. You did for football.
Sorry.
Yeah.
This is for cricket, right? This is for cricket. This is for cricket, correct? So what should be
Okay.
the value?
0.4 into
0.4 into
0.6
0.6 and
plus
0.5 into
0.6 into
0.6 into
0.7.
0.7.
0.6 into 0.7.
So this should be 24. This is 46, 42.66, 0.66. Correct? Okay,
Yeah.
so this is 0.66. Now, what else you have to calculate for
C intersection.
this? Okay, so this
C
you can write it
intersection
like this.
0.33 into probability of football.
See, okay, yeah, you can calculate it from here, right? What is the value you're getting? There can be any other method. Yeah, there can be. No, there can be any other
Yeah,
method.
someone said C into like someone said the answer actually.
Probability of C
Probability of
into
C into probability of F.
Would be 0.33 into probability of football to get the intersection.
1 second. Let me think of this. So this is what you have to calculate. You can calculate in that way also. Probability of C, C given F into probability of football. Do we have this all information? This information we have calculated. Probability of somebody playing football has been given. No. Probability
No,
of
it's
C
not
given
given.
F is given.
C
No?
given F
Probability
is
of
not
C.
given.
We can calculate it, but like how we calculate it for cricket.
No, we
This we
don't
can
have
calculate.
C.
Yeah.
We don't have
have,
C
right?
given F, correct?
C given
We
F
don't
we
have.
can calculate, right? C given F. Yeah.
We can do like 0.33 into probability of F, and we can find probability of F.
Okay, so probability of C intersection F. This is what you have to calculate, right?
Yes.
This you
So
can calculate it like, this you can calculate, right? C given F. Just think of this. Okay, given. Let me just write it as. Okay, so if you have to write it, probability of C intersection F given F into probability of F. This will
yeah,
be
it will
what?
come same.
This is what you will get, correct?
Yes, because C intersection F is same as C intersection F.
This is correct, right? If
Yeah.
you are getting this, you can directly calculate. Now you have this value, right? This value has been given here, 0.33. This is what? This you can calculate it. This you can calculate directly, right? This you can calculate probability of
That comes
F.
up to 0.44 P of F.
So it will be correct. So now you'll be having 0.44 multiplication of 0.33
by 0.66.
So, no, sir, 0.33 and 0.66. This will be the answer.
The answer is 0.22, is it?
0.1. Yeah, 0.22 should be the answer. This is a
Thank you.
complex problem, but will not be getting this type of problem, I guess, in the exam. But basic Bayesian base theorem you
Actually,
can get it in the exam.
we have something like this in the graded part, which I can't. It's related to going late, rain, heavy traffic.
The problem with base, like, it's not the base theorem problem, because sometimes what happens, we don't understand what has been written. Like, the person who has written the question only understand what they have written.
Yeah, exactly. Sometimes the English is
So,
little tricky.
yeah, and it
The
happens
language
to
is
like it happens. Any of the book also can give you the same thing. Like,
True.
you'll not be able to
Agree.
understand the English.
Agree.
Yeah,
Totally agree.
especially this part, the last, that is probability of C intersection F, condition of F. This is where we are stuck, I guess.
Yeah, I also have to say that like the way you formulated it, like P of G, P of B, P of F given B, those things, no, not like identify those things
It
and
is very
recommend
Yes,
this.
yes. We can't
That's the
able to
tricky part.
define. Yes.
Yeah, that's the tricky part.
Yeah.
The formula is easy. Just deriving this form is
Identification
difficult.
is difficult.
Correct. Correct.
So
Yeah,
that
so
it is
that's why I was saying.
contingency supposed to learn. Even strongly we supposed to learn contingency. Then only it is possible.
Yeah. No, so that's why I was saying that in the probability thing now, if you are using the formula, most of the time you'll be wrong, I guess. Like, if you're
No, but
going
for questions like this, we have to use the formula.
for base theorem, you can't go directly base theorem, but for the conditional or for the multiplicity, all those things now, go with the basic approach. Even formula, if you are able to write it all these events and all these things nicely, you will be able to use the formula nicely. Like, you'll be always correct. But what I feel is, it is very difficult to write this. Like, even knowing event itself is very difficult. How will I write A1 given A2, A2 given A3, A1 intersection? So those also is
Yes,
better to
correct.
go with the basic approach, and you'll be. So we have solved almost every question with the basic approach, except this Bayesian and the law of probability. Like, even law of probability also you can solve it. You can just think of, okay, from where it can come from head. If you have to get head, from where you can get it. Okay, so you can calculate that also. But for Bayes theorem, you'll have to identify the events and all those stuff. Okay. Other than that, everywhere you can go with the basic thing. You can just read the question and try to solve it. You'll solve it. Even permutation, combination, anywhere. You don't have to use a formula. But for Bayes theorem, yeah. Because the numerator part is like tricky.
For this problem, a simple Venn diagram could have been.
Venn diagram also.
We assume the total number of students and put those things. Now count the number of students and it will be easier. If these formulas are confusing, Venn diagram will give a clear picture. I have solved it.
Okay. Then
So,
yeah. So somebody can try
can
with that
you
method also.
share Can you share that image, sir? Like how we have solved?
I have, but I don't remember the exact numbers now. So if you send me the numbers, I can probably send you my. I don't have it with me.
Okay, got it.
I know this is some percentage playing cricket and some playing this.
Correct. For Venn diagram, we can.
Numbers were different, so I don't want to confuse with those. So if sends me this, maybe for tomorrow or sometime I can share it. Or send me a mail, I will send it to you.
Sure, sir. If you can just share the email, and we will send.
Okay. So so that is it for the today's session. We'll meet again in the upcoming session. I also have to go somewhere, so thanks everyone.
Thank you so much, Vishal.
Thank you so
It was
much.
great. Take care, man.
Yeah.
Bye.
Thank you so much.
Thanks everyone for joining the session. Bye.
So when can we expect that mock session?
Yeah, mock session after this USA ma'am session, you can expect.
Okay.
A session on the mock. Yeah.
You'll be sending mail, right, pertaining to this? The session scheduling.
You'll get a mail. Yeah, correct. You'll get a mail regarding the session. There can be a session, or I guess there can be a solution video. So any of the two can happen. Yeah, but for maths, session will happen. Yeah.
Max will be happen, but stats also right now becoming harder than like max. So that if it is like math session, there will be some important things. So kind of thing we can have a clear picture about the
Okay, I'll make sure that the session happens. The mock session also happens.
Thank you very much.
Okay, thanks.
So that
Thanks.
we'll have a clear picture of the question paper, sir. That's it.
Correct. Yeah, correct.
Thank you, sir. Have a good day. Bye.
Thank you, sir. Have a good night.
Okay. Good night, everyone. Bye.
Good night, sir. Bye. Bhaskaran, sir, I have sent you my email.
Yeah, I got it. I'll send it.
Yeah, please share.
Good night.
Good night, sir.